In Chapter 2, Section 5, as I said, we're going to be dealing with inequalities, which means we're going to have one of these four signs involved. Greater than or equal to, less than or equal to. So back in Chapter 2, Section 1, we solved linear equations. Yes, that's what we're going to be doing. Yes, that's what we're going to be doing. Okay. We solve linear equations. Linear meant, remember that it was first degree on the x. Okay, and we've been doing that ever since, haven't we? Every section we've had to end up solving linear equations one way or another. Now we're going to solve linear inequalities. So instead of having an equals there, we'll have one of these other signs, like maybe a greater than or equal to, or something of that nature. So the question is, how do I solve something like that? And what does it mean to solve something like that? What are we actually finding when we solve an inequality? Well, I'm going to tell you that first. We're finding all the values of x that make this statement true.
So these are linear equations?
Linear inequalities. These are linear equations.
So we're going to be solving linear
inequalities.
Okay.
So let me put some context to the statement I just made. We're going to find all the values of x that make this statement true. For example, if you take 100, 2 times 100 is 200, minus 5 is 195. That's greater than or equal to 10, isn't it? So 100 is one solution to this equation, but there's a whole bunch more. We're going to find all of them, all the numbers that make this statement true. How do we do that? Well, we do this the same way that we do this, with one exception. There's one exception. So we're going to write a sentence into our notes here in just a moment. And if you understand that sentence, then you really understand everything you need to know to solve linear inequalities. But before we write that sentence, let's think a little bit in this little box right here. And it'll make sense out of the sentence that I'm going to write. So I want you to go back to 2nd grade. I do this a lot, don't I? My teacher was Mrs. Tennyson. Who was yours?
2nd grade?
Mm-hmm.
You know what? I can't remember.
Really?
I really can't.
Must have made a great impact on your life. I'm just kidding. Who was your 2nd grade teacher, Megan?
Miss Hess.
Miss Hess. Okay. Was she good?
Yeah.
Okay. So Miss Hess gave Macon this problem right here, and her directions were compare. And we talked about that the other day, didn't we? That I learned the arrow points to the smaller number, and you guys learned the alligator eats the bigger number.
Yeah.
Is that the way it works? So either way, the sign would point this direction, right? Now, if I divided both of those numbers by -1, I'd have -3 and -5. Now which one's smaller?
-5.
-5 is smaller. Because what I did was I went from the right side of the number line to the left side of the number line, right? And everything's backwards over there. So if I divide by -1 to make the statement hold true, I have to switch the inequality sign, don't I? Okay. That's always true on an inequality. So now we're ready for our sentence. Maybe I'll type it in. Maybe the writing will be nicer if I do that. So here you go. If you, can you read that? Let me make it bigger. If you multiply or divide both sides of an inequality by a negative, comma, and let's pause. Okay, now notice it says if I do this by multiplying or dividing, I have to do this. It doesn't say anything about adding or subtracting, right? This only applies when I'm multiplying or dividing, and it has to be by a negative. So if I multiply or divide both sides by positive, then I'm not going to do this. But if I do both sides by a negative, then switch the inequality sign. Okay. You guys down with that? Got it off the screen a little bit. Shrink it back in on the screen, David. Yeah, it's pretty good, isn't it? Okay, shall we try a few? Shall we? Shall we? Let's do a simple one first. Let's work our way up. X minus 7 is less than negative 12. So, the big picture idea is still x is on one side, constants on the other. So to get the constants on the right side, I'd have to add 7. Am I flipping an inequality sign? No, because I didn't multiply or divide both sides by negative, right? So no, I'm not. So the negative 7 and the positive 7 cancel. And the x is by itself. That's what we were trying to do. And negative 12 and plus 7 is negative 5. So I get x less than negative 5. Now, your book is going to ask you to express your answers 3 different ways. Remember we talked about 3 different ways in Chapter 1 with inequalities? I didn't put any of these on the test because they're going to be on this test. Okay, so one way is set builder. So one way to express the first answer is to write the set x such that x is less than or equal to negative 5. This vertical bar means such that, so it means all the numbers x, and then we're defining what x is, and any number that's less than negative 5 is part of our set. So, with that in mind, let's see if you understood what I just said. How many numbers are in this answer? What did you say, Salvador? An infinite number. Everything that's smaller than negative 5 is part of this answer. Do you see that? Okay. Now, do you remember graphing these way back in the first section? So that's another way you're going to have to express your answer. So we went to negative 5. You don't need to put in every little hash. Just put a 0 and then a negative 5. We're going to shade to the left because I want everything that's less than negative 5. Do you remember whether I use a parenthesis or a bracket? Parenthesis because I don't want to include negative 5, right? So parenthesis at negative 5 and shade to the left. Okay, so that's expressing the answer graphically. Now let's express the answer in interval notation. And that's the one where we put the smallest number and then the largest number. But here we don't have a smallest number. Do you remember that we said when the left arrow is colored in, we start at negative infinity? Yeah. Yep, that little thing. Infinity always gets a parenthesis, whether it's negative or positive. And we do have a biggest number on our interval. It's negative 5. So there you go. On all these problems, you're going to have to express your answers 3 ways. Okay, so that's a good intro to this lesson.
So there's 3 different ways we have to do our.
Yep, you're going to have all 3 of these. Each one's very close to the last one, but with each one there's something I want to make sure that I mention to you. So let's go to this one. 14 plus 2m is less than or equal to 3m. And the directions on these are going to say solve, give your answer graphically, and in interval notation. Now, here's the reason I want to do this problem together. We got to get the m's together, right? And with an equation, I told you it doesn't matter which side you put the m's on. And that's still true for an inequality. However, I prefer to put them on the left. And I'll show you why that's the case at the end of the problem. So let's put them on the left. So I'm going to subtract 3m to both sides. Now again, I did not multiply or divide both sides by negative. I subtracted 3m from both sides. So I don't need to change an equality sign yet. So 14, 2m minus 3m is negative 1m or minus m, less than or equal to, and everything cancels over here and I got a 0. I'll subtract 14 from both sides. And I'll have negative m is less than or equal to negative 14. What am I going to do to finish? Divide by negative 1. Now there I am dividing both sides by a negative. So the sign has to flip. Usually the way that we show that is to circle it and point it back the other direction. And so we end up with m is greater than or equal to 14. Which, technically speaking, would be the set m such that m is greater than or equal to 14. Now, let me show you something here. If I would have put the m's on the right side, my answer would have ended up being 14 is less than or equal to m. Now, do you see that this is the same thing as this? 14 being less than or equal to m is equivalent to saying m is greater than or equal to 14. Same thing. The reason that I prefer putting m's on the left is when I go to graph it, I can shade the direction of the arrow if the m is on the left. If the m's on the right, I have to reverse the shading. You see that? So I just always put them on the left, and that saves that little bit of confusion. If you want to do this, it's fine. It's not wrong. It's just as good an answer. You just have to remember to be careful on your graph, that's all. Okay, so let's go to our graph now. So let's say here's 0. And out here is 14 somewhere. So Hannah and Josh, should I put a bracket or a parenthesis on 14?
Bracket.
I should put a bracket because I got the less than part. So bracket on 14 and shade to the right, including the arrow.
And you put a bracket on there because it's got the equal?
Yep.
Okay.
Means we want to include the 14. And then in interval notation, this time I have a smallest number. It's 14. It's included, so it gets a bracket. But I don't have a largest number, so the right arrow is colored in, so that gets infinity. Infinity always gets a parenthesis. So here are the 3 parts of our answer. Easy, moderate, or hard?
Moderate. I guess I'm still kind of confused on when to do brackets and when to do parentheses.
If it's got this or this, do brackets. If it's got this or this, do parentheses.
And on the right side, the second, like where the infinity is, will that always be a parenthesis there
Yes.
for the second one?
Anytime it's infinity or if it's negative infinity, it always gets a parenthesis.
And the parenthesis means that it
Is not included. And if you think about it logically, how do you include infinity? It goes on forever.
right. So the bracket means it stops there, and then the parenthesis means
No. The bracket means 14 is part of our answer. The parenthesis means it wouldn't be part of our answer. So let me illustrate what I mean. Let me show you how 14 is part of this answer. If we go back to the original problem, if I put 14 in here, I'd have 14 plus 2 times 14, which would be 14 plus 28, which would be 42. If I put 14 in over here, 3 times 14 is also 42, and 42 is less than or equal to 42. So 14 made our original statement true, so I want to include it. That's why it gets a bracket. A bracket includes. Now, if we compare that to this problem up here, the answer is x is less than negative 5. If I put negative 5 into the original problem, I'd have negative 5 minus 7, which is negative 12. But negative 12 is not less than negative 12. So negative 5 is not part of the answer. We go all the way up to negative 5. Negative 4.99 would work. Negative 4.9 would work. Negative 5 itself makes the original statement not true. So we don't want to include it, so it gets a parenthesis. Good question, hopefully an acceptable answer. All right. Now, I'm going to introduce you now to something called a compound inequality. And all a compound inequality is a compound sentence written mathematically. That's all it is. What's a compound sentence? In English, what's a compound sentence? Bill went to the store and Bill bought a Snickers bar. What's a compound sentence?
2 parts.
2 sentences stuck together with and or but or however or something like that, right? That's compound. Okay. In math, it's the same thing. It's 2 statements in one. So, look at this one. Negative 2 is less than or equal to negative 3k minus 1 is less than or equal to 5. We are making 2 separate statements. One statement that we're making is negative 2 is less than or equal to negative 3k minus 1. And we're also making the statement negative 3k minus 1 is less than or equal to 5. Okay? So in essence, that's equivalent to saying negative 3k minus 1 is between negative 2 and 5. Okay? Now, how do I solve a compound inequality? I find all the values of k that make this original statement true. That's how I do it. So, we're going to proceed as normal, except now what I do to one side, I have to do to all 3 sides of the inequality. Not 2. I have 3 sides. Thank you. Mercy. So how would I start to get the k by itself here?
Subtract 1 by all.
I wouldn't want to subtract 1, I would want to add 1. But if I add 1 in the middle, then I got to add 1 on the right, and I have to add 1 on the left. What I do to one side, got to do to all the sides.
So you just pick one to start out with?
No, I'm trying to get the k by itself, so I had to get rid of them. I had to get rid of the minus 1. And then after I get rid of the minus 1, then I'm going to have to get rid of that negative 3. Because the idea is to get the k by itself. Okay, so what have I got now? Negative 1 is less than or equal to negative 3k is less than or equal to 6. So Hannah, what's my next step going to be if I'm trying to get the k by itself?
Hold on.
Okay.
Add 1.
If I add 1, that's going to give me another plus 1. That's going to put me right back where I was. That's going to give me a plus 1 here with my negative 3k. I want to get the k by itself. So what do I have to get rid of?
The negative 3.
How do I get rid of negative 3?
You add 3 to 6 and negative 1.
Close. I'm not subtracting 3 from k. I'm multiplying negative 3 by k.
So you would divide.
There you go. We're going to divide all 3 sides by negative 3. Now,
Then you have to flip.
that's right, because I did all sides by a negative. So all the signs got to flip the other direction. Good thinking by one Jericho. What's your last name, Jericho?
Johnson?
That's what I thought, huh? You know I've got a niece named J.C. Johnson?
No.
I've got a niece named J.C. Johnson.
That's close to my dad's name. My dad's name is Jason. Almost the same thing, right?
No kidding. So negative 1 over negative 3 is positive 1/3. Now the sign is pointing the other direction. Here the negative 3's cancel and the k is by itself. That sign is also pointing that direction. And 6 over negative 3 is negative 2. So what are we saying? What does this answer mean? Let's wait a minute, David. It means if I pick any value that's between negative 2 and 1/3 and put it back in up here, that statement will hold true. That's what it means. Okay, so one way to write our solution is to set k such that 1/3 is greater than or equal to k is greater than or equal to negative 2. Graphically, let's say here's 0, negative 1, here's negative 2, and over here's positive 1. I want to shade everything that's between negative 2 and positive 1/3. Now, would I use brackets or parentheses? Brackets at negative 2. Oops, make that a little thicker there. Bracket at negative 2 and a bracket at about where 1/3 would be. And shade in between. And an interval notation, this time I've got a smallest number. It's negative 2 that gets a bracket. And I've got a largest number. It's positive 1/3. And it gets a bracket. Boom. Shaka. Laka. What do you think, Mr. Josh Ott?
I don't remember it from last semester.
Huh. Who's your teacher last semester?
I don't know, it's really a fall guy.
Oh, yeah?
Let's break out a random song.
Yeah. Gotcha. So, I had a student, I'm not going to tell you that story. You guys might know who I'm talking about, never mind. So,
Go ahead and tell us.
no, I'm not going to.
Just tell us the story and don't say it.
No. In case you missed it, I'm not going to tell you. Good try.
Thank you.
Okay, so our assignment's going to be on page 99. Let's start on number 11. Let's go to number 38. And on that section of problems, I'd like for you to do every third problem. So that means 11 plus 3, 14, plus 3, 17, plus 3, 20. And keep doing that until you get to 38. Okay. Then maybe 47 and 49. I'll tell you what, I'm going to give you an application problem. We didn't do one like that in this section, but you can try it, and if you have trouble with it, you can ask about it next time, but give it a try and see what happens. What's the worst that can happen? You get it wrong, whoop-de-doo. Okay, 11 through 38 every third, 47, 49, 65.